Scratch is a graphical programming environment and online community that was developed in 2003 by Mitch Resnick and the Lifelong Kindergarten Group at MIT's Media Lab. They knew that getting started in programming could be intimidating, and they wanted to create a space where people could play and experiment with code. 15 years later, their project has taken off and is used by programmers of all levels and ages all around the world. In Scratch, people are able to mix together sound, graphics, and other media, and even remix other Scratch users' projects. You're about to get started in one of the most popular graphical programming languages, and I really think you're going to love it. After all the time that we've spent talking about programming languages and algorithms and how we get a computer to do what we want it to do, it's finally time to get started in Scratch. Scratch is a block-based programming language. It was developed by MIT, the Massachusetts Institute of Technology, to teach programming concepts. And later this year, and as I said, this is a block-based coding system, we will be actually translating those blocks into a text-based language. So blocks-based coding, this is one of our high-level options for coding, and Scratch uses blocks to represent scripts. Some other examples of block-based coding languages would be Blockly, Elemental, and Snap, and there are plenty of other ones. In a previous set of slides, we looked at how we would get a computer to show the word hello, and you can see how that would happen in Scratch by clicking on the green flag and using a purple block that says hello. Text-based languages are completely typed, and Scratch is not like this. It is considered block-based, even though you can see that in the Hello World example, there had to be a little bit of text typed in there. But by and large, Scratch is block-based because it's all about stacking blocks of code, and there's a limited amount of typing that you would have to do. Both text-based and block-based languages have advantages and disadvantages. Block-based languages tend to have a palette of commands to choose from, so that you don't really need to memorize how to type those commands. But it might be a little bit slower to code something in a block-based language than one where a user could quickly just type commands using their keyboard. Some text-based coding languages would be Python, Java, C. So the question is, why do we start with blocks? And of course, if you remember from previous lesson, block-based coding allows us to focus on the logic in our program rather than the syntax. And this is really important for the AP exam because it tests the logic that you're building over the course, but you do not have to produce any code except for your create performance task. Some people worry that, well, because it's blocks based and it has bright colors and it has animals, that it's for babies. And that is not true at all. When you go through the Scratch forum, you will see projects by computer science professors at colleges and universities and college and university students using Scratch to prototype their programs and to test their algorithms. So it is definitely not for babies. Scratch is great because once you create an account, you can create programs and set up different sprites and all kinds of things, and it will save it under your account. So you really won't have to worry about saving your Scratch project somewhere else like a Google Drive because they will all be saved to your account. And you should pause the video right here and refer to the instructions under creating your page. Now that you have your account set up, it's time to take a look and see what we can do with Scratch. So after you've clicked the Create button, this is the screen that you're going to see. And over on the right-hand side, you're going to see a preview area. That's where you'll see a preview of your program, and you can see the different sprites that are involved in your program and different properties of those sprites. Additionally, you see something called the stage. So let's take a look at these. First is the cat. The cat is, by default, the first sprite that is going to be added to your program. The different properties, including the name of the sprite, the position of the sprite, the size and direction, and whether it's showing or hidden, are all available to you right there. Now, you are not stuck with this cat. If you don't like cats and you want something else, you can always go down here to the lower right-hand corner of the screen and click on the cat face, and you can choose a sprite. All right, and you've got access to a whole library of different sprites to choose from, and you can search by category. So I could change my cat. Oh, I haven't changed my cat. I've actually added to the cat. I've added an elephant. So now I've got 2 sprites in my program, and I can always go back and delete the original cat, or I could delete the elephant. I think for now we'll just go back to the cat. All right. When you add a new sprite, the sprite comes in with certain things already added to it. For example, our cat has already come in with 2 costumes. And I see that because I have clicked on this tab in the upper left-hand corner. We've got code, we've got costumes, and we've got sounds. And so under costumes, I can see that there are already 2 costumes that have been added. One of them looks like the cat is kind of in motion, like running or jogging, and the other one looks like it's still. And so obviously what you could do with that is that you could set up a little animation, making it look like the cat is walking by switching between those costumes. You could also add a new costume where you draw a mustache on your cat or something like that, or add something to his hand that he's holding, that he's running with. And the cat also came with a sound. There it is. And you have some access to some of the controls that you can use to adjust the sound to what you want. Let's listen to. Okay, that was a reverse meow. That was kind of weird, right? You can also add a sound from the library. That's that same little icon. And when I hover over each one of those sounds, I can hear it. Hear a little preview of it. So feel free to experiment with the sounds. Probably your teacher will want you to have some headphones for that. And you can do the same for costumes. You can add another costume to the cat. Another way to get a new sprite, besides choosing a sprite from the library, is to actually paint your own sprite. This works nicely when you need boxes and circles and different things to show up as sprites, like when you're making a game or something. It's very nice to be able to come over here and to paint a sprite. You could also take another sprite that you find in the library and you could change it. You could change the coloring or make it bigger or smaller or something like that. So you do have the option to work in both vector and bitmap format and to create your own sprite through this paint-like interface. You can additionally you can get a surprise. And sometimes these are very surprising. Let's see what I get. Oh, a knight who's running away. So you can just, oh, surprise me. I don't even care. And you can just click on that and it will. Also, if you have something saved on your computer that you wanted to use, you can click on this upload button and you can select that image. It will take the standard formats of images and you can use that image in your program, which is neat to be able to do. But back to the code. We can also take a look at the stage. Okay, the stage is separate. When I click here in the lower right-hand corner on stage, I can see that I've got one backdrop added to my stage right now. Backdrop 1 is just plain white, but I have access to this other backdrop right here, and I can access again a whole library of different things. And I could set this up to look like a concert. Okay, suddenly the tone of my program has changed. My cat is the star of a concert. And when I clicked on stage, I'm not sure if you noticed this, I'm going to click back over to my sprite and take a look at the left-hand side of my screen. When I'm on my sprite, I see the normal code, including motion blocks. But when I click to my stage and my backdrop, notice that the motion blocks are gone. And that's because your backdrop doesn't move. You can certainly change it, have it go away and have another one show up in its place, but it doesn't have motions associated with it, like our cat does. But other than that, we do have access to looks and sounds. We can modify the backdrop. If I wasn't a fan of the whole purple thing that they had going on there, I could maybe modify this backdrop to look a little different. And again, there's a sound, a little pop that has been brought in for this. And of course, I could access different sounds. But those sounds are for the backdrop rather than the sprite. On the stage, you have the same options for backdrops. You can choose one from the library. You can paint one on your own, which again is nice if you need like a particular background for like a maze or something or a particular color. And then you can get a surprise and you can upload a backdrop. So that's how you get started in Scratch. You choose a sprite or 2 or 3. You choose a backdrop. And in the next few videos, we'll talk about how to make this cat do what we want. Know a little bit about the Scratch environment. Let's talk about how our sprite can interact with other aspects of our program. So over on the left-hand side, you can see that this is our code section. We're on the leftmost tab, and we have different color-coded sections of options that we have. And we can either scroll all the way down, scrolling through the different parts, or we can just click directly on sensing, which is the part that we're going to talk about. For sensing, you'll see that there are several different shapes of blocks that we have. The first shape that we've got is a hexagon. All right, it's kind of an elongated hexagon, but it has 6 sides. And when we drag this into the scripting area, we can see that when I click on this, I get this little pop-up that says false. Okay, and that's because the one that I selected says, and notice it has a question mark at the end of it, so it's asking a question, is my sprite, the cat, touching the mouse pointer? And if it is true, I'm going to get a little pop-up here telling me that it is true. However, right now, my mouse pointer is over here clicking on this block, and so of course it's false. I can also select some other things. I can ask if my sprite is actually at the edge, and I could drag it over there, and now it does return a true value. All right, so the hexagons are called Booleans, and they are true-false. They ask a question to which it can only be answered with a true or false. Now, otherwise, we have these blocks here that are ovals, and these ovals are actually going to return a value. So if I click on this one, I get a number, and it's telling me that it is 118.27 units away from the mouse pointer. And that's the only thing I can select on this one. Okay, and now it has moved further away. All right, so you can see that you have that. So we've got sensing in terms of being able to sense whether something is true about the sprite. We have sensing in the respect that we can find out different values as they relate to the sprite. And then, of course, we do have some other things that we can use over here that can access our microphone if we want. And I'm going to click don't allow just for right now, but you can access those types of values as well, those analog values. All right. When we keep scrolling down, or again, you can click to operators, we find the next set of values that allows our sprite to interact with its environment. And you see your standard math operators. We see our add, subtract, multiply, and divide. And of course, the order of operations certainly applies. So if you're doing a multi-step type of operation, you do have to remember the order of operations when you put your equation together. Notice that there are, again, ovals for values, and there are also hexagons. And this will return a true or false. It's true or false that something is greater than 50. True or false that something is less than 50. Okay, and you can, of course, change that number. Then we can place two Booleans together and find out whether they are both true, one and the other is true, whether one or the other is true, or we can actually access the opposite value of that true or false. We can concatenate right here, so we could actually join two words or two phrases together, and it will make one string out of that. And we can also kind of process different words, different strings that we put in here by accessing an individual letter or the length of the word or something like that. Or is it true that a string contains the letter A? All right. There are a couple sections of, we can actually round things, and we can use the mod operator, which we will talk about much later. And we have access to, I'll just pull these over, some pretty complex operations, including sine, cosine, tangent, arctan, with logarithms, and lots of good stuff. So we have access to some pretty complex operators that we can do a lot with for our program. All right, a couple of other things. Let me go back to motion, and I'm actually going to drag these away, and I'm just going to put together a quick little script to say when the space key is pressed, I want my sprite to move 10 steps and then to say hello for 2 seconds. Now, if I had spent maybe a little bit more time on that, and if I thought that that was something, I'm like, boy, I'm going to use that again and again. I think I see myself using that script very frequently as I go through this program or other programs. What I can actually do is I can take that script and I can drag it down into my backpack. Let me just pop that up. So I can click up. Right now it's telling me that my backpack is empty, but I can drag this script in there. And now I can see that my script has been added. Now that will be available to me in any other program that I'm writing. So when I click out of this one, even if I forget to save it, that script is still going to be there in my backpack, and when I start a new program, I will have access to it. So it's very useful when you do want to reuse code. One other thing that's nice, again, if you do a lot of work on a sprite, if you did a lot of custom work, you did a lot of work in the drawing interface, you had lots of costumes that you had added to your sprite, and just you had really, it was something that you were proud of and you might want to use again as the character in another game, you have the option to right-click on your sprite and export that. And what that export will do is it will save a copy of that sprite into your computer, or onto the hard drive of your computer. And then you can actually, when you go to choose a sprite in another program, you can access that file, that downloaded file, and upload it into your new program. And so that's really nice if you created a really cool character that you want to reuse in another game or program. One other note about some features that you have access to in this environment, down here in the lower left-hand corner, you have the ability to add in some extensions. You have access to some libraries of commands that aren't included with the basic interface, which is kind of how a lot of programming languages work. If you want to work with some special hardware or write programs for hardware, you have to access that particular library. So in Scratch, you have extension libraries for music. If you want to actually compose music beyond just having little sound effects, that's really nice. And you have access to the pen features, which allow your sprites to actually draw for you, which is nice. You can access the webcam and use that for motion sensing and things like that. There's a nice collaboration with Amazon Web Services that it does require Wi-Fi. You see that a couple of these do require Wi-Fi. Some of them even require Bluetooth. But you can actually add some text-to-speech features, which is really cool. Translating with Google Translate. If you have access to some of this hardware that I was talking about, for example, Makey-Makeys, microbits, which are little programmable boards, Scratch can actually help you program one of those, and you just need to add this library to your program. If you've worked with any of the Lego products, you can even program the We-Dos, which are kind of for younger students, and the EV3s, which is really nice. So these are some cool features that you have access to that aren't in this normal code section. You just need to go in here and add the libraries if you want to access those features. All right, since you are close to getting started on your first project, let's go into some more specifics about some things that you can do in Scratch. First, let's talk a little bit more about these motion commands that are here, this blue palette. Let's take a look. I kind of threw this script together earlier for the previous example, but let's pick it apart just for a second. And let's look at what happens when all by itself, when I click on this command. And I want you to watch the cat on the right. Okay, when I just click one time, it runs this command and it moves the cat 10 steps. All right, now with regards to the cat and its properties, take a quick look at all of the information that you can see when you have selected this sprite. We can see the name we've been given the sprite, but we can also see the X and the Y coordinates of the sprite. So watch that section again as I click this one more time. Okay, I can see that because I moved 10 steps, I have now added 10. I had a -4 as an X value prior to that, and when I ran it, now it's showing me a +6. And if I click it one more time, sure enough, +16. All right, so I can do the same thing when I go ahead and look a little bit further down in the motion section. I can actually set specific coordinates that I want my sprite to move to, or I could get this one over here, which actually, if you think about it, does exactly the same thing. It adds 10 to the X position, which is what the move command does. But if I wanted to move vertically, I could do that here. All right, so now the Y coordinate is changing. It was 22, 32, 42, so my cat is moving up the screen. If I want my cat to actually move down, I could change that to a negative number. Okay, now it's coming right back down. So those are some of the things that we can do with motions. There are some other things that you'll want to play with. If on edge bounce is a good feature, so your sprite doesn't go running off the screen and never come back. You can set the rotation style. This is a nice one. You can make your sprite only go left and right. It will flip left and right according to which direction you have it moving. Or you could have it not rotate, or you could allow your sprite to free rotate, which will allow it to rotate 360 degrees. Sometimes we want that, sometimes we don't. So that's a good one to know how to use. And then I just want to point out, even though we can see the X and Y position of our sprite in this box over here, we also can use what are called reporter blocks. Whenever you see this little oval, we talked about how an oval is a value. I can actually bring this over, and if I click on it, it reports 36, which is the X position of my sprite, positive 36. If I wanted to, when I'm testing my program, a lot of times it's really good to be able to watch the values change of the different variables in your program. So I could put a check mark in there, and now I have put this on my screen. And I can show the Y position, and I can even show the direction that my sprite is facing. And the nice thing about that is, here in my preview, I can have access to all that when I'm clicked on the sprite, but when I go full screen, I wouldn't see those things anymore. So when I use the reporter blocks and I test full screen, I can actually continue to see those values, which is nice. But for now, I'm going to uncheck those. And I think I'll clean up my screen a little. This has dragged a whole bunch of blocks out. I'll get rid of them. The next palette that we come to, either by scrolling or by clicking, is the looks palette. And here we have access to our sprite being able to either say or think things. And we can change the look. We can change the costume of the sprite. We can even, from this sprite, we can have this sprite change the backdrop of the whole stage, which is pretty cool. So let me just show you these two things right here. So when I use the say, I can type whatever I want the sprite to say in there. I'll just leave it at hello for right now. I get the cartoon looking talking bubble, right? The diacritical. When I click here, notice that this is the thought. So, this is only thinking, not saying out loud. So your sprite can think certain things without other sprites in your program knowing what they're thinking. Then you can adjust the time that those bubbles display. There we go. We do have a few things that we can report. Notice we do have show and hide commands. We can set the default property of our sprite to be either shown or hidden right here in the sprite preview area. But in the program, if we want the default to change, we have access to these right here, the show and the hide. And, oops, can't do them both at the same time. Right now it's showing, so I will choose hidden. And notice that it did adjust this right here. And then I can show again, and there it is. Okay, so we do have that. So we have a couple of reporter blocks. That's what I was scrolling down. For example, size. Right here, you can set a default size. If I want my sprite to be smaller, I can change the size to 90, and that will change it by default through the whole program. However, during the program, I can change the size of the sprite also. So it is nice to be able to have these reporter blocks here that let us know what backdrop number, what costume number, and what size our sprite is. So those are good things. When we scroll through sound, we have different commands about playing the sounds. Now, the sounds have to be added. So if I want any other sound to be involved in my program other than that, I do need to add it here. And once I've added a sound here, oh dear, quick, choose something. B guitar, there we go. Now, when I go back to my code, now you'll notice that over here, I can play either meow or B guitar. Or I could record something. That can be a lot of fun. Or embarrassing, one or the other. So you have access to playing the sounds until they're done, starting the sound, and then maybe causing something in your program to cut it short if something happens. You can, if you have a cacophony of sounds going on, you can just stop them all at once with this command right here. And you can play around with the pitch and the sound effects that you have going on. You can also change the volume. Okay, and the reporter block here would be the volume. And that's going to report the value, whatever volume we have set. If the volume is changing during the program, by default, they're all at 100%, but you can certainly adjust that, and that block will show you. Now we get to events. And those are pretty important because before, when I wanted my sprite to move, I had to click this block individually, and I had to click it. If I want my sprite to say hello, I've got to click it. But we don't really want that when we have a program. We want things to happen automatically, or we want a more event-driven type of program. And so these event blocks, notice that the way they're shaped, they're up at the top, nothing can go above them, but everything else connects below them. Now, when I do click the space key, or whichever of the other keys I want to use, I'll just leave it at space. You know what? I'm going to go ahead and set everything back to 0. And by the way, if your sprite does like run away from you, it runs off the stage and you just can't get it back, all you have to do is go and change these values back to 0 and you'll have it exactly where you want it. And direction, which is 90, you can drag that around, and I would want 180 for pointing down, and so on and so forth. So you can use these, or you can just type what you want in here. If I want -90, now my sprite is flipped the other direction. So that's just nice to be able to do. So anyways, when I have the space key pressed, sure enough, I've moved 10 steps. I can see that I've pointed left, and so I moved the direction I was facing by 10, which put me at -10, and I saw that hello. And if I press spacebar one more time, there we go. So that's a good thing to have access to. The next panel we come to is our control panel. And if you remember, we talked about a couple of keywords. We talked about repetition and we talked about selection, and how those two things can really drive your program and can direct the flow of logic through your program. And so this is where we find those things. We find those things that tell our program that if something is true, then do this. Otherwise, do this other thing, or repeat something a certain amount of times, or pause everything in the program, this wait for a certain amount of seconds. And so that's where, in the control section, this is where you control the flow of logic through your program, through repetition and selection. And we already talked about sensing. We talked about operators. We will definitely cover variables at another time. And we will also talk about my blocks and how you can use those to create procedures of your own. The last thing I'll show you is that in this extension library, which I did show you before, you can access something called the pen. Okay, and when you do your Cat's Meow project, if you want to add the pen library and the commands that come in with that, and you want to have your cat actually draw its path as it dances, that's definitely something that you can experiment with, and that's kind of a fun thing.